All right, so welcome everybody, and thank you so much for joining us on this episode of Set Talks. In this episode, where we have the distinct pleasure of having a quick conversation with Dr. Timothy Lethbridge, and he's the Vice Dean of Governance at U Ottawa, and we're super happy to talk to him about software engineering and career paths. So, Dr. Lethbridge, it truly is a pleasure to have you with us.
And it's a pleasure to be here with you.
All right, so why don't we start off really quickly? Can you tell us a little bit about yourself and your role as a researcher and as a professor? What do you do?
Okay, well, I have three main types of roles. The role of a professor is quite complicated. I obviously teach undergraduate courses, so I teach courses in software engineering, particularly focusing on software modeling. That's the high-level design and usability. And I teach at the graduate level as well, the students who are doing their masters and PhDs. So that's the teaching part. Then I'm also a vice dean, so I'm responsible for a number of issues, sit on many committees, making decisions. And finally, and certainly not least, I'm also a researcher. And so my research is in the area of software engineering tools and making them usable. Particularly, I have a project called Umple, UMPLE, which you can look up on the web and explore. Basically, that's a tool which will help people to design software and generate code from software, so they have less coding to do, and they can spend more time focusing on adding features and doing more interesting things than low-level coding.
Yeah, definitely. So you mentioned your project Umple. Looking at like some of the things that you've done, you're part of one of the research group, I think complexity reduction
Yes.
in software engineering. So I want to ask you, just like, especially with how you mentioned code reduction and making software engineers more focused on the actual like implementation of working code. How is Umple actually used right now, and what applications do you see it being used for in the future?
Well, it's used to design the high-level structure of the data and the behavior of the code, and you can then blend in any other complex code you want in several programming languages, including Java and PHP and C++. You can draw diagrams of your code, and those diagrams can actually update the text, and to some extent vice versa, right? Your text will update the diagrams as you go, so that you can kind of see what the system would look like at the very high level. People have often drawn diagrams of code before on systems, but very often they draw the diagrams and then they go and write the low-level code. Whereas with Umple, you draw the diagrams and those diagrams become the code automatically. The diagrams are converted into code. And so that saves a lot of effort. And so you don't have to have separate documentation. In fact, any comments you write in your code are also reflected in the generated code as well. They will appear if you hover over parts of certain diagrams, that some of the comments will appear there. So it allows you to really have a good understanding of the system. Umple itself is written in itself, which is a little bit unusual for software engineering tools. We made a big effort to say, if you're going to build a tool, you got to make sure it's usable, and you got to make sure you use it too to build itself, so that it guarantees the quality to some extent. And it's used by open source developers, because open source developers like writing text, but it's still useful for them to be able to generate some of the code and to be able to draw some diagrams of it. And finally, of course, it's used in teaching and education. A lot of students, undergraduate students, may have been taught how to use UML tools to draw pictures, but they then became a bit disillusioned with that, because either they have to use very complicated tools, or else they just have to simply, after they've drawn the diagrams, write the code. Whereas at Umple, you can do it all in one step. Just draw the diagram, and there's your generated Java or whatever language.
Yeah, definitely. Like I could definitely see like me. I'm actually a software developer myself, and I feel like if I could just have like do it all in one step in one place, and skip all like the boilerplate code that you might actually have to implement, which is kind of like a chore in my opinion. And if I could actually focus on like the real fun things, I could definitely see that. So yeah.
Now, of course, in software engineering these days, there's a lot of frameworks you can use which reduce the need to write boilerplate code. And so Umple is just one of many tools that are out there. But it covers a certain ground, like the design of the data and the design of the behavior that a lot of these other tools are not quite up to yet, although we're actually trying to make Umple work with many, many other tools. So I have a lot of students this summer working on that with me. And in fact, Umple has been written, the compiler and the website have been written almost exclusively by students. I think I've had 7 PhD students, several master students, and over 60 undergraduate students working on it over the years, for the last 12 years.
That's interesting. So it's interesting how, you involve everybody in that. How important do you think it is to get undergrads and people who are just starting off? How important do you think it is to get them involved in hands-on projects and stuff like that?
But I mean, I think it's extremely important. I mean, in our software engineering program at the University of Ottawa, co-op is mandatory and it's highly recommended for computer science. So that's co-op jobs that are where you're paid for employment. But Umple is an open source tool. It's free, and all the work has either been volunteer work or has been part of fourth-year capstone courses or degree courses. As any open source project, it's taken on by people who want to contribute and deliver something. I mean, most of the similar tools are commercial, so they've been built by big companies, whereas what we decided to do is we wanted to build a tool that is open, anybody can use it, and anybody can contribute to it as well. I mean, I'm the project manager, but anybody can contribute, and we try to follow all the best practices, and in fact push those practices even further. So for example, we use test-driven development, which means you got to write tests for everything. But also we use what's called model-driven development, which means you've got to do design for everything. And heck, you know what? Umple is all about model-driven development. So it's really pushing the envelope of doing best practices. And as new practices come along, we look at them and we say, well, we're going to do that in Umple as well. And so students who work on Umple, developing it as a tool, are also learning some of these best practices as well.
And so you talk about Umple, and this is an exciting, you're pushing the frontier of software development and software development tools. And it's probably, this field is probably one that's extremely dynamic and ever changing. So could you talk to us about how you've observed the field of software development and software development tools? How has that changed over the course of your career?
Well, my first actual program, I mean, I learned how to program a bit in high school back in the very beginning of the 80s. But I did my undergraduate degree from 81 to 86 and 85, sorry. And during that time, my first semester, I was using punch cards. Second semester, I was using a terminal. And by the time I got into my master's degree in 86, we had online exams for the first time, and things were really had progressed a long way. During that time, I did co-op, and I worked for the government of New Brunswick. And in my first co-op work term, they kind of imagined people would write code by hand and send it to a typist to type into the computer. I said, I don't want to do that. Why would I do that? That would be so complicated because they're going to have to correct what the typist typed. So, that was the end of the early phase of computing. It was interesting that I had actually got to experience that. Since then, I mean, a lot of the techniques that I witnessed the early stages of, like, for example, agile development, where you do small iterations, but you write tests. That was something that I was involved in a little bit in the early part of my career. I kind of said we should do this, and people were looking at these ideas back in the early 80s and 1990s. I remember doing my PhD, writing a knowledge management system. We wrote lots and lots of tests, and we had really fantastic language called Smalltalk to develop in at the time. But some of the things that have been coming about more recently are really this deep emphasis on agile development. All the big companies are doing agile development. There was a time when, people said, well, we have to do big requirements and big design, get all the plans down and then code. And that's called waterfall. And I went to a talk about 20 years ago where the person who coined the term waterfall said, and he coined the term in the 1960s, he said, I intended that to be a pejorative thing, a bad way of doing things, but people took it as me saying it should be done that way by mistake. Anyway, people have finally realized in the last 15, 20 years that waterfall is terrible, and most organizations are not doing it. There's still some place for it in you're developing, nuclear power plants where you kind of have to specify all the interactions with the hardware and safety analysis and so on. But for most software, agile is the way. The other big thing that's coming in, of course, agile implies, unit testing and many other techniques, tight iterations, interaction with users on a constant basis to make sure that you're building the right thing. If you make a little change, it doesn't work for the users, you throw it away and you go back, because that way you're not going to have this big thing that has to be thrown away at the end. You know that you're on the right track all the time. The other thing which has been pushing forward in big waves in the last 10, 15 years has been the frameworks. Node.js, for example, being an example of a backend framework, and there are many, many others. React for developing websites that work on multiple platforms, tons of them. This has been a big trend as well. And people can get so much done so well, so rapidly. However, there is one constant problem, and that is that a lot of software still has huge usability problems. Even today, I sometimes go and look at some new software, whether it be on an embedded device, just thinking about the washing machine I purchased or the microwave oven, and I say, holy crow, they didn't really know how to do a good job of user experience design for this. And I got my, a year or so ago, Rogers came out with a new website, and it's slow as molasses, even slower than the previous one. They didn't realize that they need to focus on what are often called the Nielsen's 10 principles of user experience, to make all systems, whether they be websites or devices or standalone software, highly usable for people. I did some research 25 years ago to say that was the biggest gap in industry. It still is today. So if you're going to focus on something, that's a big area to look into.
Yeah. I actually, I really think that your last point there, where you talked about usability, user usability, I've seen some talk about like how, especially like you mentioned with websites, they're bloated and they're slow despite our hardware getting faster and faster. So like, what do you think about like having like software kind of like lagging behind developments in hardware, along with like Moore's law? How do you see that?
Well, yeah, I mean, the idea is that people develop frameworks that use an awful lot of CPU resources and try to do all kinds of fancy things, all kinds of animation and so on. And that's fantastic, as long as you still can keep your response time super fast. That's one of several dozen things you need to do. As soon as your response time slows down, and I'm not talking about being just because you're using a slow network, I'm talking about because you're trying to download tons and tons of JavaScript into your web page, and often also you've got slow database access and a number of other things like that. That's not the only problem. That's not the only user experience problem. I mean, many times people just don't have access to adequate help. I mean, hover over something and you should see a pop-up saying what it is after a few seconds if somebody's trying to figure it out. That's often missing. Often complicated technical language is used. Tons and tons of little problems that software engineers and other software professionals should really focus on if they want to do a really good job. And industry needs that. Most companies now are putting programs in place to try and improve their user experience, but there's way too many people out there who just don't get it.
That's funny. About not talking about like issues and problems that software engineers face, I would like to ask you if you have any advice that you would like to give to any ambitious high schoolers or undergraduate students that actually want to like break into the field of software engineering or pursue a career in software engineering. Okay,
so a few things. First of all, one thing to remember is that it's a diverse field. It's not you're going to be doing coding. First of all, it's diverse in terms of the types of systems. Developing real-time systems for vehicles is a totally different category than developing websites for e-commerce, which is another totally different category from, say, developing games. There's dozens of these categories, and each of them requires different types of technologies to learn. And if you don't like one, you might like the other. Another thing is, it's not all about coding. You do need to learn to code. And I would say learning to code is a bit like learning to play a musical instrument. You get better over time, and practice and practice and practice and practice makes perfect, right? Thousands of hours of practice to become a virtuoso musician, same thing to become a virtuoso programmer. So take the opportunity to code your own games, code your own fun things, and join open source projects and contribute to them. But it's not just coding. I mean, there's also, as I said, there's the design issues, which you get into probably a little bit after you've learned how to code, because you can't appreciate design until you kind of understand what impact it's going to have on code. But then there's also the user experience design we just talked about, and the user requirements. There's testing, which is another totally different category of skill, right? Some people might be good at coding, but they might be not so good at testing. And so, get used to thoroughly testing your software manually, and also writing tests that automatically run. That's a big thing today. But if you're in high school and you want to get into this, take a good, solid programming course. Try and get yourself access to a computer where you can do some programming for yourself, program some games, get into some kind of group where people think that coding is fun. I remember that's what happened to me in high school. I got into some groups of kids who were really, a little bit geekish at the time, but I mean, there's nothing wrong with that, and we just would do some coding. I remember coding, long division and calculating pi and things like that for fun in grade 12. That was either on big mainframes which you had access to, or early Apple II computers and things like that. And then, if you want to get into this field, and oh, by the way, one more thing, and that is it's not just about coding and sitting in front of a computer. It's also a human thing. Interacting with people is a big part of it. It doesn't have to be. It's diverse. There are people who can spend all their time coding and not interact with people much. If you're very much an introvert, it's possible. But most people who are software developers will need to interact and will benefit strongly from interacting with clients and users, talking to your users, demonstrating to users, finding out what works for users. So it can be a very human intensive thing. And, if you're into humanitarian causes, there are lots and lots of charities and humanitarian organizations that need people to build software for them. So you can volunteer for those kinds of things. The sky's the limit. I do recommend getting a university degree, but you might take it as a minor or a major or an honors, and maybe have another subject as well, because in software development, knowing some other topic will be very useful. For example, I took quite a lot of business courses when I was an undergrad. I took accounting up to third year and some electrical engineering courses, and that was really useful because I can code financial stuff, and I wouldn't have been able to do that if I hadn't had that background. But there was people at the University of Ottawa, for example, who do coding for music. There's a piano pedagogy group who focus on intersection between computer science and learning piano, all kinds of things.
I don't think we can end it off on a better note than that. So Dr. Lethbridge, really want to thank you so much for taking the time out of your busy schedule to do this. I learned a lot. I know that. Hope Derek did, and I hope all of our viewers did. So thank you so much again.
Okay, bye-bye.
Right, take care.